Today's A+ question is, use prime factorization to help you subtract these fractions. So we know that when you're subtracting fractions, you have to have a common denominator, so we're going to focus on the denominators and use prime factorization with both of those numbers to complete this process. So let's start with the number 25. 25, if we factor that, becomes a 5 and a 5. Both of those numbers are prime, and so we can simply say 25 is 5 times 5. If we find the prime factors of 45, we might start with 5 and 9. Of course, 5 is prime, but 9 is not. So we can continue to factor that to its prime factors of 3 and 3. So we know that the prime factorization of 45 is 5 times 3 times 3. Now, the first thing I'm going to do with my subtraction problem is rewrite both fractions, but write the denominator in our prime factored form. So the first one becomes 3 over 25. I'm going to write that 25 as 5 times 5. And my second fraction, 2/45, I'm going to write it as 2 over 5 times 3 times 3. Now we know when we are subtracting fractions, we have to have a common denominator, and one of the ways that we can do this is find that common denominator by looking at what prime factors the other denominator has that we need to bring into each fraction. So if I'm looking at this first one, I see that the 5 is in common, but this first fraction doesn't have a 3 times 3. That's the part I'm going to have to add. 3 times 3. And of course, whatever I do to the bottom, I have to do to the top. Next, I'm going to look at I'm going to change that second fraction by looking at what the other fraction has that the second fraction doesn't. In that case, it is a 5. Notice that this first fraction has 2 5s and my second fraction only has 1 5 on the bottom. So I'm going to have to multiply by 5, top and bottom. All right, now we're going to go ahead and subtract. And what we're going to get is, I'm going to go ahead and just write these in a more standard form. 3 times 3 times 3 is 27. 5 times 5 times 3 times 3 is 25 times 9, which is 225. And I'm going to subtract that from 2 times 5, which is 10. And on the bottom, of course, we have the same denominator because it's the same prime factored form of the same number, 2 5s and 2 3s, so that's going to be 225 as well. When we subtract that, we get 27 minus 10 is 17, and our denominator stays the same. So let's actually try this with another example. I'm going to try to use prime factorization to subtract the fraction 17/24 minus 5/16. Again, we just care about the denominators as far as the prime factorization goes, so we're going to go ahead and make our factor trees for both of these numbers. 24, we can say, is the product of 2 and 12. 12, we can break it into 2 times 6, and 6 can be broken into 2 times 3, so the prime factorization of 24 is 2 times 2 times 2 times 3. 16 breaks down into 2 times 8. 8, of course, breaks down into 2 times 4. 4 into 2 times 2. Of course, you may have recognized that 16 is equivalent to 2 to the 4th power, which would make sense that we have 2 times 2 times 2 times 2. All right, so now I'm going to rewrite these fractions, but use the prime factorization as my denominators. So I have 17, and instead of writing 24, I'm going to go ahead and do 2 times 2 times 2 times 3. I'm subtracting from that 5/16, which I'm going to write as 2 times 2 times 2 times 2. I'm going to check out what each one has in common. I see that that's 3 2s are what they all have in common. That means that this first fraction needs another 2 with it. And of course, if I change it by multiplying something on the bottom, I have to multiply the same thing to the top in order to keep it an equivalent fraction. And the second fraction here, it needs a 3 in order to be common with the other. So we can do multiply by 3, and of course you do the same thing to the top. Now it's basically, we just have to rewrite these again in standard form. 17 times 2 is 34. And now I have 2 times 2 times 2 times 2 times 3 as my denominator. So 4 2's and a 3. Well, the 4 2's, of course, is 16 times 3 gives me 48. And I'm going to subtract. Now I have 5 times 3, which is 15. And on the bottom, I still have a 48. 34 minus 15 is 19. And we have 48 as our denominator. So there you go.